that actually you can apply that using your linear regression and also multivariate. That's the first thing. Second thing is that here basically how we can apply that in agricultural data. Now thing is that if you have any particular data set, I am teaching in such a way so that after that also you can do hands-on, and the what are the softwares, how to do that also I'll tell you later on. That first of all, that whether you can actually suppose any type of means you have any type of means data. Now how the classification can be done, that means that classification that is based on your information retrieval, and those retrieval techniques, those should be basically in an optimum manner. So in this case what happens that on the agriculture data set, how we can actually do the naive-based classification algorithm, and how the ANN can be used in order to find out a computational technique of optimum F1 score. Now see, in this particular work, that means this particular case, the thing is that the machine learning how they have actually used, that means the decision tree and KNN and also artificial neural network. Here the SVM they have actually used on the basis of nonlinear kernel function. Now why it is so? Because you see that if there is basically a perceptron model, in perceptron model, then basically your hidden layers, that the computational technique, that is the most important thing, because ultimately you should have a input output basically factor. Now the number of hidden nodes, that depends on your computational activity, that what you actually want. Now in this case what happens, on the basis of real agricultural data set, the naive-based and also the ANN actually those can be applied. And here what happens, you see basically I am not going into such details because I have to cover random forest also. Just one thing I'm telling you, in this particular work they have actually used the maximum marginal hyperplane, and there they have used the two techniques. That means one is basically a upper triangular matrix and another one is a lower one. So in this case the support vectors how they have actually used, that is basically based on their use the concept of your empirical risk minimization using learning algorithm. Now when I'm telling learning algorithm, here you can use the supervised technique and also unsupervised technique. But sometimes in case of your modeling, what happens that suppose if you are actually doing a particular time frame, suppose T1 to T10. Now when it is T1 to T10, you have actually recorded a particular means data set, that means these are the records. Then how after that T11 T12, how we can actually get the data, that means the correlation of data. Now here you have to find out that fine whether there is any sequence of pattern. That means if it is a pattern analysis, in that case it is fine. That means you know that whether it is your ascending AP series or whether it is basically seasonal pattern or cyclic pattern. Based on that you can understand, okay, then in the next time frames those things can be done. Another thing is that suppose I am telling that your that irregular pattern, in that case what will happen, that means you have to find out the curve fitting concept. That means whether those particular basically the data fitting and whether that affects, that means y is equal to fx, how much actually accuracy you can achieve. Now when I'm telling accuracy, you know, in case of whenever we do any type of curve fitting, we can use a polynomial expression. Now your polynomial expression of suppose your order in order, that means the more the order will increase, so the overfitting that we get, and accordingly your accuracy will be there. In this particular part, your particular your paper, you can see that the Lagrange function that actually can be applied. Now when it is there, that means whenever the Lagrange function has been applied, that means there should be some optimum class function. Now they have actually done the classification that how based on the your theoretically using computational learning theory, they have used the computational learning theory, how this sigmoid graph that changes. That means in this case study, you see they have actually used the parameters, that means your real classification class C they have actually used. That means one is basically belongs to TPFN and one which is not belongs to. That means in this particular case these are basically the index functions, and accordingly these are actually the recall and precision. Now in this case, how you can do Weka 3.8.4, that is basically a tool. It's a software tool, it's an online tool. You can use rapid miner also. There what happens, any type of agricultural data, here also they have used agricultural data, the CSV file you can actually upload, and then you can apply two things. One is basically the two types of technique you can do. One is basically the resampling, and another one is basically the class balancer. Now it depends on that whether you will use how much cross folds you can use. Cross folds basically means, that means whether it is 10, 20, 30, then accordingly you're here in this case you're basically the sensitivity, specificity, capacity, and also the precision. The accuracy that can be optimum, that is no problem, but the precision is most important, because there you will actually measure that how close the various your outcomes at different timing instance they can be implemented. So in this case they have actually used the linear function and as I told you, the default kernel function of SVM. So here you can understand that from this particular Weka based analysis, the F1 score, that is 67.3%. Okay, and now another thing is that here they have actually shown that fine, that means below 70%, that is the accuracy limit. So in this case, that basically means that in this case the recall and the precision and the F1 score, that is fine. That here the limitation is that it has not been optimized. That means here you can see that through SVM they have used 10-fold cross validation. So how the your through ANN or naive base, how you can do this? That means here you can increase the cross fold. That means here they have used the 10-fold cross validation. You can use the 20-fold and the 30-fold. In that manner you can find out a graphical analysis, and ultimately we can estimate sorry, that okay what are the algorithms you can actually design. Now another thing is that in this particular paper they have not mentioned something. They have not mentioned that, later on I'll share these papers also. In this particular paper the limitation is that they have not used, number one, there is no optimization of the parameters. Number two, here they have actually worked on basically the hyperplane concept. Now when you use nonlinear kernel function, there the delay comes into picture. That basically means what? That means that your in case of topology, from your input layer to your hidden layer and then again to your output layer, so the computations, there are certain delay. So how to minimize the delay? It is known as the jitter, JITTER. That means that minimization of the delay, if you can actually do, in that case what will happen, the sensitivity and specificity, that also will increase, and accordingly your accuracy will also increase. So this is the first part. Second thing is that, wait, yes, now as I told you that okay, SVM, that means the multi-class, that means the linear, while you can use the binary classification, and another thing is the multivariate, that means the multi-class. So in this case here also they have actually used your multi-class support vector mapping application. Now here what technique they have actually used? They actually use the rapid miner also, and also through Python they have actually set up that what are the correlation among the parameters. That means in this case you see here the implementation of multi-class support vector machine algorithms they have actually used, and accordingly they have actually summarized the methods, their performance and accuracy, and ultimately they have found out that which one is the best fit or the best method. That means here the algorithm, see there are various algorithms which you can use. You can use your supervised algorithms also, you can use unsupervised algorithm also, and in certain cases you can also use the reinforcement learning also. That is a new technique. That means what happens, that you can use your adaptive neural networks, you can use the recurrent neural networks, that how those can be actually means applied. Those things here they have not applied. That's the limitation of the problem. So in this case you see, I'm not going into the means this thing. In this case you see, one thing is that here one algorithm, that one against all algorithm, that means initially it was there. That means basically what, that if there are certain number of elements, that means they have used actually separate data points. That means each category of SVM is trained to separate the data points from the data points of other classes. And when it is so, that means through Venn diagram, you can understand that if there are certain classes, then the intersection of that means those are the common features. That means those common features are basically the desirable features. And after that, if a particular class is different from another, because ultimately your C1, C2, Cn, all the classes should be distinct. Now, if it is distinct, that means that particular class should have at least one actually feature, distinct feature that actually marks it is C1 and it differentiates from C2 in this manner. So here, first, initially what happens that here the binary SVM, they can be trained. That means it is based on the linear regression model, and accordingly you can get a particular value. Now, in case of if the dimension is much more, that means from binary, suppose it is in dimensional, that means in number of indexes will be there. That basically means when that is the case, that means those number of classes that you have to use under subclasses. Because see, when the number of classes is much more, then you can also do the searching or information retrieval or the data analytics in parallel processing manner. So when it is a parallel processing manner, that basically means what? Suppose C1 to Cn, then C1 to Cx you can do in one timing frame. From Cx1 to Cy from another in this way. That means in certain quartiles, you have to actually. Yes, tell me. Hello.
Please check.
Yes.
Dr. Chakrabarti is Dr. Prasenjit is okay or not? Because
okay or not, please.
Means he is online listening on. Dr. Prasenjit.
Hello?
Yes. Yeah, I'm listening.
Any problem?
Yeah, continue, sir.
Otherwise,
okay.
Just check feedback in between, because online we don't know. You are taking
yes.
And afterwards.
Yes, Dr. Prasenjit, one thing before again continuing, I'm telling you here, all the research papers I have actually used based on your profile. Okay, Professor Poda send me your profile. So all applications, these are oriented to your agriculture. And after the end of lecture, I'll send you also the softwares which are open source softwares where you can upload the data also. Okay. So you see these concepts are very, very unique. And another thing is that here the directed acyclic graph support, here also it is another very important thing. That basically means what? That basically means this you can apply everywhere. That means when we do certain subclasses, then in those subclasses also there can be overlap. So if the directed acyclic graph, that basically means in this case we have to vote. That means how vote? That means suppose you train n number of classes, then the voting that should be does not have the bounding on the generalized error. That means what? In this case, suppose a binary classifier, then that basically means what? If there are two classes, that means to separate your features. If there are basically in class your classifier, that basically means in different types of distinct classifiers. So there will be now 100% accuracy is not feasible. Herein comes the concept that fault tolerant. That basically means what? That basically means there is you all know that the threshold value of the bias. So threshold value of bias that we can say based on the supervised learning technique. Now, suppose a particular random value has come. Suppose the value is x, and suppose your supervised your random mean that means that your bias is y. That means if x, I am telling the mod value, mod of x minus y. Suppose it is a delta. Now this delta is a deviation. Now, whenever we will accept that model or not, I am telling now the error means optimization and the fault tolerance limit. Whether we will actually accept that model or not, that depends on the criteria. That basically means what? This delta, that means the expected value and the actual value, the mod that is equal to delta. Now that delta is how much? That means there I also have to set a offset value that if delta less than equal to beta, then it is the model is accepted. If delta is greater than beta, then it is not accepted. That means when the moment the delta is greater than beta, then you know that through backpropagation neural network, you have to readjust your weights, you have to readjust the parameters, and accordingly, your aim is ultimately the actual value minus the expected value mod. That should be new delta, which will be less than equal to beta, which is the offset value. Same technique is here, that in this case also they have actually trained until unless that particular your means voting technique, that means that's why they have no bounds on the generalized error, because everything depends on the offset value. Another thing is that very interesting concept that we all know that binary tree, that means there is a root, there is a left subtree, and there is a right subtree. Now thing is that if we do the coding in error, that means here the coding theory how we can apply. Suppose I am telling that there are level 0, level 1, and level 2 and level 3. That means, as we know that in case of any decision tree, if it is a complete binary, then the first thing is the root. That means in L0, level 0, that will be only one node. In level 2, it will be 2 nodes, because ultimately in level 3, that means your third layer, that will be actually 4 nodes, that in this way. So if we make the index positions of the levels from 0, 1, 2, 3 in this manner, so the first level, the maximum number of nodes is 1, which is nothing but 2 to the power 0. In the second case, it is 2, which is 2 to the power 1. In the next level is 2 square. In this way, it will continue. So it is nothing but basically a GP series. That means 2 to the power 0 plus 2 to the power 1 in that manner, plus dot 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 up to 2 to the n. That means in this case, if we do your binary tree, so the coding theory will basically what? In the next level, the left subtree we can assume as 0, whereas the right subtree we can assume as 1. So in this way, in every level, every node has basically a binary code word. And this code word you can do, this is actually used in case of information theory. That means if we actually want to classify each, in this case, each class, that means each node will designate a particular class, and these are distinct values, because ultimately the code word of a particular node is different from the code word of other. So in this case, what will happen, you see, the purpose is here very simple, that in this case, first area agriculture, as I told you, that 1 against 1, 1 against all, and acyclic. In all these cases, we actually use the linear kernel, and here it has been tested that the better accuracy there. Now, whenever in the second case, it is basically the medical, in that case, your EEG, ECG signals that can be coming, and that you can use in any type of disease. So here, the main concept is that how the classes you will generate, which technique you will use, that will depend on the parameters and the data set. Second thing is that you see, just wait, that how, as I told you, that the multi-class, so your SVM, that is fine. But in this case, that means you have to use the multivariate analysis. Now, when you use the multivariate analysis, then how the classification can be done? That means main thing is that first thing, that whether it is any crop or whether it is any agriculture, then how the fruit vegetable automation means classification you can use. That means in this case, you see that if you do the standard multi-class SVM, then simple thing is what? You make the features you extract. Once you do the features, then you apply the multi-class SVM. And then after that, you should increase the robustness, because ultimately the sensitivity, robustness, and the accuracy you have to do. Second thing is that suppose in certain cases, there, you know the concept of missing data. That means suppose you want to achieve something, and there the missing data basically means some of the data is missing. So in that case, you have to do the approximation theory. So based on the same theory, when you approximate that something, that means it is basically fault tolerant, because by default you are actually accepting the error. Now simple case is that when it is basically the categorize the fruit disease in this case on the base of images. Now here it comes, when it is basically images, that basically means what? In this case, your convolutional neural network will come into picture. Now, when you use the image, that basically means from a particular frame to another frame, here the delay analysis plays a very, very important role. Second thing is that when you are doing this, that means you are doing the neural modeling, then here the pixel positions, the values of the pixels, those are basically and the weightage of the pixel, because which pixel is actually of equal priority or not, which pixels are of prior value or not, that means accordingly your weights will be adjusted in the neural model. So here what happens, when you actually use the computer vision and multi-class SVM, then by default your previously it was nonlinear, and now here it is multi-class kernel support vector machine that you have to use. That means in this case, since it is based on images, so obviously you can understand that there should be a color histogram. Now when it is a color histogram, so there should be a texture and also the shape feature that can be used. So in this particular case, how now if you want the prediction, Prediction based means what? That means the forecasting. Now, when it is forecasting, then which technique you will actually use? That means whether you will use the probabilistic value, or whether you will use the fuzzy value, or whether you will use actually the Bayesian statistics. That basically means in this particular case, the soft computing technique we have to use. Now, whenever we use the color or shape extraction of features, in that case, your genetic algorithm comes into picture. There what happens that certain parameters which are the best in genetic algorithm, do remember that all the parameters will not use. That's why in genetic algorithm there are some significant parameters and there is some insignificant parameters. So based on the weightage of, and here also which one is your significant, which one is not significant, that depends on the supervised value. That's why the supervised in learning mode, you have understood that okay, the proportion of this one, that means the support of these particular parameters, these are actually of high priority and other things are of less priority. So accordingly, your feature extraction will take place, and there you can use the genetic algorithm. Now, another thing is that you see that sometimes you can see. Yes,
sir, this is not clear.
Yes.
Genetic algorithm, please repeat it. I am not getting it. The genetic algorithm.
Yes.
CNN was fine, but genetic algorithm, please explain it.
Yes, I'm telling. See, in this particular case, what happens? CNN, you have understood that how your particular case is coming. That means since it is based on texture and frame.
Yeah.
Hello.
Yeah.
Have you understood?
I know. Feature extraction and then predictions.
Exactly. And can you tell me in that feature extraction what are the limitations also? You know. In the feature extraction, that means basically what? That means in case of feature extraction, how the pixel optimization, those things can take place. That means those are basically the case. Now, when I'm telling the genetic algorithm, first thing, just wait. What happened? Just wait. Where was just 1 minute.
Yeah.
Hello.
Yeah. Continue.
That can you see the paper?
No, it's not coming right now.
Just wait here. Yeah. Just yes. See now, genetic algorithm. Listen how it differs. First thing, do remember that it is basically that means optimization problem. First thing for optimization problem. Now, how you can do that means optimization problem can be of two types. That whether it is basically constraint or basically unconstrained. That means in this case, in this particular case, how the genetic algorithm you can actually use. Simple thing is that suppose here there is set of parameters or variables. That means say I am not going into your biological terms here, because normally what happens, genetic, that actually these variables, these are actually known as the genes. Here what happens that when we actually make the genetic algorithm, that means it is based on the natural selection. First thing. Now, how you can use the genetic algorithm? That means in this case, it is nothing but the heuristic search algorithm. That means heuristic search basically means what? That means from a particular point to another point, how you can actually go. That means the initial state and the goal state. So in this case also the same thing. In case of genetic algorithm, it is basically based on that what are the minimum number of steps so that you can reach from an initial state to the goal state. Simple example I'm telling you, that suppose from A to D, A is your source and D is your destination. Now from A to D, there may be certain many paths, A, B, C, D, another thing, A, E, F, D, in that manner. So which way you can use, that depends on your algorithm. That means whether you will use the shortest path or whether you will actually use the most appropriate path. That means it's up to you. So same thing is that's why it is telling the heuristic search. Genetic algorithm, that's why it is also known as the evolutionary algorithm, because it is based on the computation. Now, When I'm telling the genetic algorithm, that means in this case, it is basically state-based. State-based basically means what? That means the previous state, that means S-1, the current state, that means S0, and also the future state, that basically means what is the future state? That means suppose S1. Okay, that means in this case, how we can actually do this? That means why the genetic algorithm in this particular means agriculture they have actually used? The only thing is that whenever you have to find out certain input output relation, that should be in a optimized way. Now when I'm telling the optimized way, that means what? That means it based on certain things. That means optimization also has certain techniques. So first of all, suppose there is a huge data set, that means you have total number of samples, many samples. So first of all, you have to make this versatile. Now when you have actually makes this versatile, that means that the versatile basically means what? That means you have to make into certain categories. And those categories, based on those categories, you have to find out certain algorithms, and that is known as the clustering. Second thing is that when we use the genetic algorithm, the one thing we should know that it should be much more efficient and also the robustness. That means in this particular case, that means now many question comes that okay, that means is genetic algorithm basically a classification? There is a confusion. Do remember that there are many classification methods that use the adaptive learning AI. Adaptive learning AI basically means what? As I told you, that means adaptation basically comes from supervised learning rule. Okay, so when adaptive your learning AI, that basically means when it is adaptive, when we adapt in order to succumb to any particular situation. Simple thing that suppose today there is cold weather. Now I want to adapt myself. So accordingly, you will actually wear a sweater. Another individual, he can adapt based on his own will. So you can see that whenever there is a cold weather, it is not that every time all individuals behave in the same way. Same thing is that in case of genetic algorithm, the adaptive learning AI you use, and when it is that when you use the adaptive AI, that comes that it is the optimization. So here the classification is not the factor. In this case, what are the main steps? Main steps is what? First, the initial condition you have to find out. Second, in any case of genetic algorithm, the fitness function that comes into picture. That means when there is a fitness function, that basically means what? That means how fit is your particular model. That is also second thing. Third thing is that in case of your this genetic after this, once the model is fit, then you have to find out the parameters. That means which parameters those are basically selected. Now second question is that the activation function. This is the most important thing. That means in this case, the activation function basically means what? That means in the genetic algorithm, when you use your subcomputer techniques, that means here which particular AI you will use, what type of neural model you will use, how many layers you will use. Everything depends on your, as I told you, the optimization, because you already have the supervised optimization rules. So in this particular case, you can actually understand that that is through evolutionary algorithm, through genetic algorithm, you can get an idea. Okay, fine. That means in this case, if we use this particular algorithm, then obviously we can get a better result. Another thing is that very simple. That is very means in very few cases it's written that okay, fine, that we use the genetic algorithm, but are there any limitations of genetic algorithm? There are certain limitations. One thing is basically what you see, as I initially told you, that we actually genetic algorithm work on the optimization. It's not only on the classification. Now when I'm telling the word optimization, that basically means what? That means optimization is only possible if there is a provision. Now if there is no provision, then obviously if you do error and trial, you do repetitive measures, but still your optimization doesn't take place, then what will happen? Your degradation is time complexity. So that is another thing. Another thing is that if a particular genetic algorithm, if these are not unsupervised, do remember that if genetic algorithms are not unsupervised, then what will happen? They are measured against a fitness criteria. As I told you initially, the fitness criteria you have to do. That means if the initial mutations they are not supervised, then obviously the system as a whole, they are either removed. That means those are not adaptable. That means we will not actually accept those things. So whether we will use this genetic algorithm or not, that actually depends on, that means that how much accuracy you want to achieve. And another thing is that in case of genetic algorithm, how we can optimize, or what are the means, in what way we can actually make the genetic algorithms far better. One thing is we can do the global optimization. Second thing, we can use the parallel processing. It is also another technique, provided there is no dependency criteria. That basically means what? I have given you a task. Suppose I have given you that A plus B plus C plus D. Now, if I tell you that A, B, I am telling you from very layman's language so that you can understand. Suppose A, B, C, D, these are certain parameters which are independent parameters. In that case, what will happen? If I give you a computational means computer or any particular computing machine, and I told, suppose this is a binary adder. In that case, what will happen? A plus B, when you will do at the same time parallel processing, C plus D you can use. But if I tell you no, A plus B plus C plus D, where the C equal to A plus B plus suppose F. In that case, what will happen? That means C, in that case, there is basically dependency. That means C value will be A plus B plus another parameter F. So until unless A plus B actually gets its value, you cannot start the value of C. So in this case, also the same case, that whether you actually perform parallel processing or not, that depends on various dependency factors. Second thing is that here, in case of your genetic algorithm, a larger set of solution space is required because your sample size should be much more. Now, the more the sample size, the more will be the prediction accuracy, the more will be the probabilistic nature, and also you can have multiple your optimum solutions. Second thing is that, just wait, my computer has become slow. Yes, this is also another important thing, that how in agriculture crop yield prediction, the linear support, here there is the linear SVM, but I can tell you what are the limitations of this and how we can actually improve this. Here also they have used WECA. You can see that in the keywords, that is WECA 3.8.5. I am skipping the literature review and directly going to experimental analysis. They are the data set they have used, the various data sets. They are what they have used, that here the 500 sample size they have kept 500, and features they have used 12. So these you can optimize, up to you. That means which features you will use. Herein lies the as I told you now, that how you can actually measure, how you can actually optimize the particular accuracy. That depends on this particular factor. That means suppose here they have used 12 features and 500 observations, and they have used 1-to-1. That basically means all 12 features they have actually used for the generation of the particular output. But my question is, if out of these suppose 12 features, suppose only 7 features are prominent, in that case, if you make the projected data set, then what will happen? Obviously your accuracy will be much more, your parameter optimization will be here. In this case, the feature optimization will be there. So using that, the sample size may be 500 observations, no problem, but there the support count comes into picture. Now here question comes, a very important thing, mathematical model you can do, that in very few papers they have used, even today's paper nowhere they have used. That means the confidence rule. What is that? That means, suppose, simple thing I'm telling you, suppose A1 equal to P1, P2 and P3, A2 equal to P2, P3, and suppose A3 equal to P1, P2 and P3 and P4. That means in this case you can understand that all the three applications, when you execute, you need the parameters P1, P2 and whatever the associated parameters. Now, when you do the support count, how, as I told you, that how you can measure that which parameters are prominent. So in your observation period, you have basically A1 to A1, A2 and A3. Now, second question is that out of A1 basically means total 3 applications. Now, out of 3, how many times your P1 has come? How many times your P2 has come? How many times your P3 has come? So accordingly, you will get a weighted measure. That means suppose P1 is present in all the cases. In that case, what will happen? It is basically 1 because it is 3 by 3. Suppose P2 is actually present only in 2 cases. In that case, it is 2 by 3. In this way, it is continued. So if we actually measure, if now comes the concept of your fuzzy weights, that now if I tell, okay, fine. So P1, P2, P3, Pn, what are the weights? So those ratios will basically the weight values. Now, accordingly, you can understand, okay, fine. So P1 is 1, your P2 is basically 2 by 3, your P3 is suppose 1 by 3. So out of these 3, P3 is the least significant feature. So if we actually eliminate that particular feature, in that case also the overall, the impact on the particular model will be much less. Simple thing is that here they have used the concept that in this case, that in the data set they have used certain things. Now they have used the SVM and also the explanatory data analysis. They are used the data analysis they have used using Weka and rapid miner. SVM also they have used using the neural toolkit. You know MATLAB. In MATLAB there are certain toolkit also. MATLAB also has several versions. So in your university lab also, if you have MATLAB, you can do the experiment that in MATLAB there is a neural toolkit that is a specific simulation tool. Or else you can do one thing, IBM SPSS. This is also another software where you can use the means your SVM, inbuilt SVM will be there, and accordingly you can run the model. And then after the model, you can understand that what is your predictive output. Now, in this case also they actually use the training set and that your test set, and you have trained the model. Here they, while training the model, again they have used the non-linear SVM, and you have seen that the accuracy only 62%. When the accuracy is only 62%, then why we'll actually choose non-linear? Because here the accuracy is much less. For that reason, they have actually chosen the linear SVM. Now, when they have chosen the linear SVM, how they've got? That means in this case also from non-linear to linear, that means they again have actually done the parameter optimization, they have trained the model, they have tested the model, and accordingly the precision value they have got 0.93, that is the 93%. Another thing is that, as I told you, that cross-fault validation, how you do the parameter tuning. In this case, you see whether if in Weka, when you upload any particular data set in CSV file, you can understand that then there you have to give the cross-fault value. So suppose it is a 10 cross-fault, so you will get a particular value using, there are two techniques. One is actually using resample, and another one is using class balance.
Yes, sir. Sir, his voice is not coming.
লাইন ইয়ে হয়ে গেছে, ড্রপ করেছে বলে।
Okay, okay. Network issue.
নেটওয়ার্ক ইস্যু।
হ্যাঁ স্যার।
This particular prediction, you can understand the more you increase your instances, obviously your particular accuracy that will be much more. So in this way you can actually understand that how the SVM that can be used. So main thing is that sometimes
Sir,
yes, yes.
is not coming.
Sir, last your voice not audible last a few minutes.
Okay, I can tell him.
You just speak a little slow, sir, because we are beginner. Means Dr. Prasenjit also a beginner. Don't think that we know everything.
Random forest also I have to cover. Okay, fine. Fine.
Just go slowly, sir. Don't go so fast.
Sir, one question is that in support vector machine, how many samples, minimum sample size is required?
The minimum sample size, it is at least 700 to 800.
SVM.
Okay, and another thing you note down, the minimum number of optimized parameters that should be 12, and normally the parameters, other parameters that can be 17 to 18. Okay, so sir, agriculture background, so obviously you can understand, suppose you want a crop, that means suppose for the yielding of that particular crop, what are the various type of fertilizers you can use, what are the various type of other things, diseases that can be the challenges, all those can be one of the parameters or one of the features. So accordingly, you can actually find out the various type of samples. Now the samples, one thing I'm telling you, please collect the samples from different places. Otherwise, if those are homogeneous samples, in that case, what will happen? Your kappa statistic and also the root mean square, that also remain the same. So as I told you, in this particular case, simple thing you see, the correct, as I told in this particular paper, they have used the 500 sample size. Now, out of that, the correctly classified instances, you see it is 481. That means total number of accuracy is basically what? 481 divided by 500. And similarly incorrect. So here, the more you increase the sample size, accordingly you will actually get that what is your accuracy estimate. So that means here in these certain cases, out of all the 3 research studies, you can understand, normally you can see in books it is written SVM is always better. It is not like that. Now you have understood that in certain cases your linear SVM, that is better. In certain cases, non-linear SVM is better. In certain cases, SVM is not at all giving good result. You can actually give with that binary tree classifier, they can give actually good result, or naive-based classifier. So depending on your data set, depending on the activation function, that is most important, either you have to find out your research finding, and everywhere you have to optimize the accuracy. Second thing is that the other part, that how in as I told you that CNN is basically means there you have to use your image processing. Now, when we use the random forest, that means in case of random forest, what happens? One thing, just wait, I'm telling you. That means here, here what happens? The effectiveness of random forest, that basically means what? That means here they classify. That means previously what happened, it is basically based on classifier, that SVM. In this case, it is both for classifier and also clustering. That means clustering basically means what? That is, if there are n number of particular classes, then accordingly whether you use how many clusters you will use, then each cluster that will basically have certain features. Now from cluster to cluster also you can actually vary. Now another thing is that this total random forest, it is based on ensemble learning. That means they use the concept of decision tree principle. There what will happen? That means when there is a decision tree, that means there should be a input vector, there should be output vector, and also there should be the decision parameters. Now when we use the effectiveness of random forest, that means there we have to use that which particular classifier you can use. That means whether you will use the nearest neighbor or whether you can use the neural networks. So here obviously you can understand that if the random forest is based on the supervised, in that case no problem. That means the based on the classification you can do. And if it is basically unsupervised, that basically means what? That basically means all the output that you are getting, those are stochastic outputs. Stochastic basically means random. Now when there is a random, that means you actually map those outputs with the following. Now I am coming into the literature review. I am skipping. There is not so this introduction also you told you know. So directly I am going that how you can apply in your agricultural part. That means the see, in this particular random forest, you can use the multispectral image analysis. That means when you actually find out the yield any crop or any particular vegetable or in your any agricultural your product, first you have to find out the image. When those image comes into picture, that means when you get the image, that means you actually digitize that image, and then you have to find out that if you want on the basis of tree classifier, then obviously you have to find out that in the images you have to find the nodes. Each node makes a decision based on the attribute value. That means those now those attribute values you can actually make the index position. That means if there are several colors, that means 0 1 2 in that way, so that the mapping table also has to be framed in a certain particular manner. That means for example that if a decision tree is to classify a fruit, then in case of fruit analysis, each node that makes a particular decision. That means because ultimately each class that should be distinct. So if you make the fruit analysis, then each fruit has a different color, different shapes. The same thing they have actually used based on taste, based on size. That means here you can understand the fruit. Here the fruit, it is basically an entity. Whereas this color, shape, size, taste, these are basically the parameters. Now, when you optimize the parameters, that means what? These fruit qualities, that means the types of fruits, those are basically different. Suppose there are n number of fruits. Now, for n number of fruits, the colors also will be there. Now, as I told you, how you can optimize. That means here also you have to find out the priority. That means which are the significant and which are the insignificant. So color, suppose out of n number of cases, you have seen that okay, small x number of cases the color is actually red. That means you can understand, okay, that means the red color, it is basically a feature whose support vector and which support count is much more. That means it is of higher priority. In this case, suppose in this case color, shape, size and taste, 4 are there. If there are n number of parameters, then n number of those statistical values will come into picture. Now question is that in this particular case you have understood that this color, if yes, that means size, if it is big enough or not, that means it is watermelon. If it is apple,
this thing I meant.
You know this thing.
Yeah,
now
but
if you know
one
this,
question,
now one thing.
Sir, one
Yes.
question is there in case of a random forest, whether this kind of image is required or this kind of data.
No, in case of random forest, if you use CNN, then image is required.
Yeah.
Okay.
Yeah.
Okay.
CNN,
Now,
yes.
Exactly. Understood? Okay. Then you know the concept. Thank you. Because this is very clear, very good, valid question. Another question you should have asked me, you didn't ask. See, in this case, you know this one. But if I tell you that here can you see that this here you can see this apple and this apple both are there. Have you seen that?
Yes.
Understood? That means in this particular case, this apple is basically feature. This apple is a feature, but the root is different. Have you seen? The root is different.
Yes.
That's why you can understand that out of these apple and apple, these are basically the features which are repetitive features. Understood?
Yes.
And grape and grape, these are also repetitive features. But watermelon, banana, cherry, grapefruit, these are basically distinct features. Understand? That means in this case, you can understand this one is basically a particular path. This one is also another path. In this case, there are some common features and also there are some distinct features. Are you getting or not? So accordingly, you can understand that basically means that these apple, grape, these are basically insignificant parameters because those parameters, based on those, you cannot segregate the classes. Understand?
Yes.
The same thing is that. Now a very, very important thing, that is the information gain. That basically means what? That means information gain basically means the entropy. That means whether a party, suppose a simple example I'm telling you, so that you can understand that suppose today you have actually gone through a particular event. Suppose you have made an accident. Now you slept and next day morning you have actually you realize that in the dream you have seen that okay, you made an accident, but it is in distorted way. That basically means what? Suppose the cycle hit you, but in the dream you have seen okay, auto has hit you, but ultimately the accident has occurred. That means here when the entropy information is basically what? It is accurate. That means the information is accurate. That means the event has occurred. That means that you have met an accident, but how the accident has occurred, that means the antecedent and consequent, there is basically arbitrary observation, which is a violating factor. So similar thing is that means here your information gain is not up to the mark. So similar thing is that in any particular class, whenever there are certain information, there are certain cases that probable classes, and there are certain classes which are basically mislead of information. That basically means, so as I told you, the missing factor or the missing value. So in that case, how you have to do? That means the gain, you can understand this one, that this gain, this particular equation, see here, this pi, it is basically error rate. That means how much error you have actually not come across. Second thing is that this is very important. You see, in this case, it is a very generalized algorithm, but I don't want to show you like this. I want to tell you that if you apply this in your agriculture, in that case, what will happen? Obviously, create a particular node, and I told you that the node, when you create, you have to first find out a topology. That means a graphical structure. So when you particularly suppose cauliflower, simple example I'm giving, you have actually clicked a particular picture and it is the image of the cauliflower. Now, first of all, you have to decide in that particular cauliflower, what are the edges, boundary edges, then you mark a sketch. Then you have to find out that, okay, fine, this is the starting point, this is the end point. So how through which route you can actually use. So same thing is that, because ultimately you have to find out the disease in that particular crop. Now when it is a disease, that basically means what? The entire space, the entire hyperplane, that is not affected. In a simple example, when sometimes we buy qualified, when you bring home from the market, you can see in certain cases there is some black spots, something that basically means that those spots are basically the discrete spots. Now those spots we have to eliminate. Same thing is that if we want to do that, then how you can actually partition that. So here the partition technique is there, that means whether we will actually use that or not. Same thing is that how you can use the your random forest. Here you have to find out in certain classes or certain segments, and accordingly you have to do. Another very interesting I want to show this thing ID3 also, random forest. These are basically the theoretical part I am explaining, because I want to show you the experimental portion. Yes, it is very important. You see the accuracy assessment, it is basically the mathematical modeling, and this you can apply anywhere. That basically means what? Suppose, as I told you, when we, in case of any neural modeling, we actually do the classifier, that means the test data and also the train data. When we do the trace data and the train data, accordingly our main is basically what? The error rate. Error rate is very important, as I told you, because ultimately you have to optimize the error. Until unless the error is optimum, your model no one will accept. So suppose this is a M particular matrix, where M is the number of classes. That means it is nothing but in the form of a confusion matrix.
Yes, sir.
Now,
This thing I know. You skip it. Okay.
This you know, fine.
Yeah.
Okay. Then that's why I don't know your background. Now, fine. So I'm going directly to this one. Yes, Irish neural network. There's a Bayesian belief network. You know this thing. You know. Should I explain or skip?
No, you skip it, sir. You just now show me that how to execute it. That is more important for my purpose.
Okay. No, how to execute that means that for that is the your practical portion you want.
Yeah, practical questions.
Okay, then that will do in the next session. I'll do it. Okay, because in the next session that I'll use it, and after this lecture I'll send you the codes also. Your email also. I have
codes, and this paper also you just send me so that I can read those papers.
Yes. And just 5 minutes you give me. Another important thing I want to show you, just another thing, that yes, estimation theory. Here, this one again I will show you. Just the index positions are there. Okay. Now based on this index position, how we can do that means here in this particular case, each particular parameter, these particular results, the correlation coefficient that actually used based on the WECA, that means the experimental year. So what I suggest today, you first download the WECA 3.8.4. I'll send you the mail right now, where all these papers I'll send. 3.8.4 first you do, and do you have the IBM SPSS? Then it will be easier for me to tell you how to process the year.
IBM SPSS 25 version.
25 version you have? Okay. Yeah. And the MATLAB neural toolkit do you have?
No, sir. MATLAB I don't know.
Okay. So neural portion, have you done anything?
Neural portion I little bit done using ANN in SPSS.
No, ANN is not a tool. I'm telling the which tool you have used for the hidden layer manipulation and the optimization function. Have you used anything?
Oh, radial RF.
Acha, you have used radial interpretation network.
Radial and perceptron
model you have used. Perceptron model.
Yeah.
Okay. How many layers you have used in hidden layer?
I have not used much.
Okay, fine. So that portion I will tell you how to utilize, and there are very good means online open source software. Okay, the academic versions are also available. That thing also I'll send you. Okay. Can you do one thing to my WhatsApp? You please send me your email ID.
Okay, sir. Sure.
You send me the email ID, then the mathematical perspective and everything, then I'll show you. Okay.
Yeah.
Okay. So Professor Shandip.
Yeah, sir. One question is there that like you explained the genetic algorithm. Genetic algorithm is a supervised, unsupervised, or reinforced learning, or it is or it can use any kind of learning.
Exactly. Here it is basically first fundamental is that it is basically based on the evolution. Okay.
Yeah.
Hello.
Yes,
can
sir.
you hear me?
Yeah.
Hello.
Listening. Yes, sir. I'm listening to you.
Hello.
Yes, sir. I'm here.
Hello.
Yes, sir, I'm here only.
Network issue.
Yeah.
So, Mr. Mijan can stop recording.